Cities face growing challenges in territorial planning. Climate change, which exacerbates issues such as urban heat islands and the overuse of individual transport, are some of the main problems of our cities. Addressing these issues requires intelligent and participatory planning. New urban infrastructures, such as bike lanes and public parks, must be built based on well-informed decisions, and our fellow citizens must be involved in this process. We neither have the time nor the resources to invest in projects that quickly prove deficient or insufficient to meet our needs. With these principles in mind, we decided to found UPlan. The company aligns with UN Sustainable Development Goal 11, which aims to make cities and human settlements inclusive, safe, resilient, and sustainable, and particularly with Target 11.3, which aims to enhance inclusive and sustainable urbanization, as well as the capacity for participatory, integrated, and sustainable human settlement planning in all countries by 2030. Our collaboration will involve public and private sector entities and companies developing urban infrastructure projects. Our goal is to create a 3D virtual replica of these projects so that the population, using virtual reality devices, can experience and test the infrastructure. In addition to gathering public opinions, we will conduct sensor-based testing to capture people's sensations and reactions. This approach ensures that decisions are informed by both the contributions of the local population, who will ultimately benefit from the final project, and by scientific metrics derived from sensory data. Currently, several companies and government entities carry out functions similar to those our company intends to implement. In London, a project addressing the construction of new skyscrapers in the city sparked intense community debate. To give voice to public concerns, the project was initially developed in 3D and later utilized virtual reality, enabling citizens to accurately visualize how the project would take shape. This immersive experience allowed stakeholders to assess whether the criticisms of the project would persist after viewing its potential implementation. The company tools gained recognition for its development of Smart Favela, a platform featuring a digital twin of a favela in Rio de Janeiro. This initiative allowed residents to vote on and monitor proposed projects. Similarly, the company Vividly is well known for creating 3D models and virtual reality visualizations, employing these technologies for purposes aligned with the aforementioned examples. We share some similarities with the Emotional Cities project approach, particularly in its use of neurological sensing as a tool for understanding spatial cognition and citizen behavior. However, it does not focus on studying or testing the construction of infrastructure projects. Our company took inspiration from the innovative ideas of each of these projects and many others, but we distinguish ourselves by integrating these ideas into a single product. We now present a case study that illustrates the potential of our service. Firstly, the interested entity presents their project. We will then evaluate it remotely, assessing whether it is feasible given our own resources. If the project does not have a 3D model, we will develop it alongside the creation of its digital twin. Then, we will initiate the deployment of our team to a location provided by the requesting entity. Virtual reality tests will be conducted with the participation of residents from the area where the project will be implemented. During the virtual reality tests, two processes will take place simultaneously. Firstly, we will collect the participants' feedback on the project through a survey. At the same time, we will also collect sensory data from the participants for later analysis. Based on this analysis, the results will be presented to the requesting entity, accompanied by recommendations to improve the project.
This slide highlights UPlan's interdisciplinary expertise in digital twins, virtual reality, neuroscience, and artificial intelligence, each led by a specialist and supported by skilled professionals to enhance urban planning solutions. Headed by Bernardo Santos, this team will create digital replicas of infrastructure. The 3D modeling specialist will design accurate virtual structures for simulations, and the GIS specialist will integrate spatial data to connect models to real-world environments. We aim to collaborate with Simons to leverage their expertise in smart infrastructure and digital transformation. Led by Martim Neves, this team will develop immersive VR experiences, The computer engineer will program interactive environments, and the GIS and territorial planning specialist will prepare spatial data to integrate in virtual spaces. We seek to partner with Iris VR to use their advanced VR tools for realistic project simulations. Headed by Pedro Santos, this team will study emotional and cognitive reactions to urban spaces. The electroencephalogram and neurophysiology specialist will track brain responses. The eye tracking specialist will analyze user focus, and the biofeedback specialist will monitor physiological signals to assess emotional states. We aspire to collaborate with emotional cities, to merge neuroscience with urban planning, creating people-centered environments. Led by Eduardo Ares, this team will develop predictive models to improve decision-making. The data scientist will analyze patterns for insights. The machine learning engineer will create predictive models, and the software engineer will develop tools to implement AI solutions. We intend to work with Esri to integrate geospatial AI and data-driven urban solutions. The virtual representation of the presented projects will be carried out through the creation of digital twins. A digital twin is a digital counterpart of a real-world infrastructure. Its increasing use in the context of smart territorial planning can be framed within two main perspectives. In the first, digital twins are created for existing infrastructures. By placing sensors on the physical infrastructure, such as those measuring air quality and temperature, detecting damage, and calculating traffic, the digital twin is continuously updated with real-time data. In the second perspective, which aligns with UPlan's objectives, digital twins are used to virtually simulate infrastructure projects that have not yet been implemented. This opens up opportunities for planners and the public to virtually test it before it is constructed. In both perspectives, it is important to emphasize that any infrastructure implemented in a city does not function in isolation, and it impacts its surroundings, and vice versa. Therefore, geographic information systems play a key role in integrating these virtual replicas with their environment, enabling a precise visualization of how the infrastructure fits within the rest of the city. While UPlan's focus is primarily on the development of digital twins for unbuilt projects, our clients also benefit from having a digital twin of their infrastructure once it is constructed. This ensures that the pre-construction process is always guided by informed and conscious decision-making, and once the project becomes a reality, its continuous monitoring optimizes performance and allows for future improvements.
To achieve the highest level of realism possible, we will use virtual reality, VR. In the past, projects were presented in 2D or 3D, but visualization was done exclusively through screens. The introduction of VR allows users to experience three-dimensional models in an immersive and interactive way. To make it possible, it is necessary to use a game engine, such as Unity or Unreal Engine. These software programs process the 3D information from digital twins and transform them into navigable virtual environments. A virtual reality headset is used. This device covers the eyes and, often, the ears as well, providing the sensation of being fully immersed in the digital environment. The headset has sensors that track head movements, adjusting the perspective in the virtual environment in real time. This feature creates a smooth and natural experience, enhancing the realism of the interaction. Along with the VR headset, index controllers, omnidirectional treadmills, and even stationary bicycles are used, allowing users to simulate real-world movement in the virtual environment, as well as manipulate virtual objects with their hands and perform precise gestures. These features expand the possibilities for interacting with the virtual environment, making the experience even more engaging. In line with digital twins and virtual reality simulation, we aim to take an innovative step forward by incorporating neuroscience into the process. The primary goal of its use is to understand how individuals emotionally and cognitively respond to different types of environments, ensuring that urban planning is guided by real people's needs and experiences. Our philosophy is based on two fundamental pillars: emotional mapping, through the identification of physical elements in planning, such as green spaces, traffic, buildings, that evoke feelings of well-being or discomfort, and decision support, which involves using the data collected to refine territorial planning scenarios, prioritizing more comfortable and functional solutions. We apply an approach grounded in precise methods and metrics to assess human reactions and emotions. Electroencephalography, EEG, an electrophysiological monitoring method, measures real-time activity, enabling the analysis of engagement, focus, and emotional states during VR experiences. The eye tracking sensor allows for monitoring eye movement and points of interest, evaluating how people visually explore spaces and which elements draw their attention. Finally, biofeedback, supported by heart rate and galvanic skin response, GSR, analysis, enables the monitoring of physiological signals, stress levels, relaxation, or emotional excitement in participants. This analysis will identify the natural and urban elements that promote well-being or require changes in planning, allowing us to propose improvements. Upon completion of all stages of our service, a database will be developed to store the feedback from the population, encompassing both verbally expressed opinions and sensations captured during the tests conducted. This database will serve as the foundation for the development of a generative artificial intelligence model. Once the model is constructed, it will be tested on projects previously completed, allowing us to compare the predictions generated by the model with the actual feelings expressed by the population as they walk through the area. The results of these tests will guide the continuous adjustment and improvement of the model. The purpose of designing this model is to predict the population's reactions in future services and identify potential issues that may cause disruptions. This will allow us to offer our product to other regions. We expect this project to revolutionize territorial planning, making it more inclusive, efficient, and aligned with the needs of local populations. By allowing residents to interact and digitally experience spatial planning projects prior to their execution, planning becomes more participatory and ensures that the opinions and perceptions of communities are incorporated into decisions. It will be possible to identify and correct potential flaws in urban design, supporting government decision-making and significantly reducing the number of post-work interventions and requalifications, which reduces spending by public and private institutions, promoting more efficient management of material and financial resources.
We design cities with everyone in mind, where every detail makes a difference in our lives. UPlan. Your eyes, your brain, our city.